Hello viewers, welcome. In this lesson, we are going to have a look at the simple electrical circuit. Now, in any electrical circuit, usually there are three things that we measure: the current flowing through the circuit, the potential differences across the resistors in the circuit, and the electromotive force in the circuit. So to help us understand all these different components or parameters, we are going to take a very simple question and then try to work around it to help us understand those components about the simple electrical circuit. So there's a question that we are all going to solve together. So let's go through it. And the question reads: with the aid of the simple electrical circuit below, determine I, the magnitude of the current flowing in the circuit, II, the value of each of the current flowing through the three resistors connected in parallel. Now, when it comes to connections in circuits, we have series connections and then we have parallel connections. Now, resistors are components in the circuit that consume the current in order to function. They consume the current and then they function using the current. Like for instance, an electrical bulb takes the current and then it lights up. All right. So the electrical resistors, they consume the current in order to function. The current flows through the circuit. Now these resistors usually have a potential difference across their ends which pushes the current through them. And then the whole circuit as a unit has what we call the electromotive force. Now the electromotive force is the work done in making a unit charge to go around the whole circuit and come back to its starting position. But the potential difference is the work done in moving a single charge across the ends of a resistor. So for instance, in this electrical circuit, we have 1, 2, 3, 4, 5, 6 resistors in the circuit. Now, resistor 1, resistor 2, and resistor 3 are connected in parallel. Now, what does that mean? What it means is that if a current is flowing through the circuit and gets to this junction, it has to divide into 3 different parts, such that we have current 1, current 2, and current 3, each of them passing through resistor 1, 2, and 3, respectively. Now, when resistors are sharing the current that is flowing into their connection, we say they are in parallel. Now, when the current flows through each of the resistors, the currents, all the 3 currents will meet at the end, where they begin to flow as a single current again through the circuit. So the whole current passes through resistor 6, the whole current passes through resistor 4, the whole current passes through resistor 5. At this junction, it splits up again and the whole process goes on and on like that. So resistor 4, 5, and 6 are in series. Resistor 1, 2, and 3 are in parallel. Now, for us to be able to find the overall current in the circuit, we need to know the overall resistance in the circuit. We also need to determine the overall EMF in the circuit. So let's see how we go about that. So we start. First, we have to attack the parallel connection in the circuit. We have 3 resistors that are in parallel. Resistor 1, 2, and 3 are in parallel. So we have to resolve them and find the effective resistance of all these 3 resistors that are in parallel. So we quote our formula for resistors that are in parallel. So we have this. So 1 over R equals 1 over R1, 1 over R2 plus 1 over R3. Okay? So my 1 over R equals 1 over R1. So my R1 is 2 ohms plus 1 over R2. My R2 is 3 ohms plus 1 over R3. My R3 is 5 ohms. So 1 over 5. All right. So my 1 over R equals. So let me get the LCM of 2, 3, and 5. So I have 30, right? Okay. So 2 in 30, I have 15, 15, 1, 15, right? So I have 3, 3 in 30, 10, 10, 1, 10, right? So 5 in 36, okay, 6, 1, 6. So this one I have. So 1 over R equals 31, right, over 30 Okay, so my R over 1, which is R, equals 30 over 31. And what does that gives me? That gives me 0.97, right? Ohms. Okay. So for all these three resistors that are in parallel, the combined resistance of all these three resistors that are in parallel is what? Is 0.97 ohms. Good. Okay. Now this 0.97 ohms is now in series with this 2 ohm, with this 2 ohm, and then with this 3 ohm. Okay. So my total resistance in the circuit RT now becomes my 2 ohms here plus the 2 ohms there, right? Okay. Plus my 3 ohms plus 0.97 ohms. So what does that gives me? 2 plus 2, 4, 7. So I have 7.97, right? Okay. So this is the effective resistance for the whole circuit. So the whole circuit as a single unit, this is the effective resistance in the whole circuit. Okay. So now we have to find the effective EMF in the circuit. So my V, effective EMF, V or E, as the case may be, what we choose to use. All right. So I have two batteries. I have a 6-volt battery and then a 4-volt battery. So these are the two batteries that I have, and they are connected in what? In series. All right. They are connected in series. So I have my V1, right, plus my what? My V2. So this gives me 6 volts plus 4 volts, and that gives me what? 10 volts. All right. So this is my effective EMF in the circuit. So that's my 10 volts, my effective EMF in the circuit. Okay. Good. So now, from Ohm's law, we know this, right? Good. So we can go on and say, well, my current is that. So V equals IR, current times resistance. So my current is my electromotive force, overall electromotive force in the circuit, divided by the overall resistance in the circuit. Okay, so I have my 10 volts, okay, divided by my overall resistance. I have 7.97, right, ohms. So what that gives me? That gives me 1.25, right? So I have 1.25 amperes. So 1.25 ampere is the current that is flowing in the circuit. So this current that is flowing in the circuit, this current, right, the value is 1.25 ampere, right? 1.25 ampere. So that is the current that is flowing in the circuit. Okay, so now the next task we have is to find the value of each of the current that is flowing through the resistors that are connected in parallel. So we have 3 resistors that are in parallel, and when the current gets there, okay, what happens? The current is going to divide. So we have I coming to the junction, and then that's going to divide into what? I1, and then we have what? I2, and then what? I3. So this is what is going to happen, right? So I1, I2, and I3, all coming from I. So I equals I1 plus I2 plus I3. So current, the overall current is called current 1 plus current 2 plus current 3. Now these 3 currents, current 1 is passing through resistor 1, current 2 through resistor 2, current 3 through resistor 3. Now because the resistors have different resistances, the values of the currents that are passing through them will not be the same. Okay, the values of the currents passing through them will not be the same. So we are now asked to find the value of each of the currents that each of the resistors is taking. Out of this 1.25, how much of this 1.25 is each of them taking? So that is the task. Now, in order to do that, we must find the potential difference across that parallel connection. This parallel connection has a potential difference. All right. So when we take resistor 4, resistor 5, resistor 6, they are all going to have potential differences across their ends. Now these 3 connected in parallel will have a single potential difference across their end. So what we are going to have is a situation like this. So we are going to have this, right? Okay. So we are going to have a potential difference across their ends. Okay. So let's call it V1. Now this is also going to have a potential difference across its ends. Okay. Let's call it V2. This is going to also have a potential difference across its end. let's call it V3. This is also going to have a potential difference across its end. So let's call that one also V4. Okay? Alright. So this is the situation that we have. So we have V1. V1 is the potential difference across the parallel connection. It's just one. For all the three that are connected in parallel, they have just a single potential difference across their ends. Alright? Now, this is going to have its own potential difference. This is going to have its own potential difference in that. Now, when we add this potential difference to this potential difference to that potential difference and then to this particular potential difference, what we are going to get is the overall EMF, which is equal to 10 volts. Okay, which is equal to 10 volts. Okay, so in an electrical circuit, the sum of all the potential differences across all the various resistors will be equal to the electromotive force or the EMF. Okay, all right. So in order to be able to find the values of each of the currents, we must know the potential difference. That is the voltage, that is the work done in pushing the current through them. Okay, the power that is being used to push the current through them. So we must find that, which is going to be different from the EMF. So the potential difference across these three resistors that are in parallel is going to be different from the overall EMF in the circuit. So we have to determine that one first. Okay, so that's what we have to determine first. So in order to determine this V, so let's call it V1, right? So V1 equals to what? IR. Okay, where I is the current that is entering into the parallel connection and R is the resistance of that parallel connection. Okay, so the current that is entering into that parallel connection is 1.25. Okay, and then the resistance of this parallel connection, the effective resistance of the parallel connection is 0.97. That's the effective resistance of the parallel connection, 0.97. Okay, all right. So when we do that, what do we have? We have 1.213 volts. Okay, so we have 1.213 volts. Okay, so this V1 that we have here, this V1 is 1.213 volts. That is the magnitude of the potential difference across the parallel connection. Okay, across the parallel connection. Then now you can go on and find I1, I2, and then I3. So how do you go about that? So my I1 is going to be equal to my V1 over my R1. Okay, so what's my V1? 1.213 volts over my R1. My R1 is 2 ohms. Okay, good. So what do I get from there? I have 0.61 ampere. Okay, my I2 is going to be equal to my V1 over my R2. Okay, so what do I get there? So my V1 is 1.213, and then my R2 is 3 ohms. So what do I get there? 0.4 ampere, right? Okay, and then my I3 is my V1 over R3. So 1.213 over 5. And what do I get there? That gives me 0.24, right? 0.24 ampere. Okay, so current 1 has a value of 0.61, current 2 has a value of 0.4, and current 3 has a value of 0.24. Now in order to cross check, we have to add. Let's add the 3 as we saw over here. Let's add the 3. So here we have 0.61 plus 0.4 plus 0.24. When we add that, what do we have? We have 0.25 ampere. So we can cross check that and see. So this, oopsie. So we have 1.25 ampere, right? Okay, so the current that we have here, 1.25 ampere, it got to this junction and then it divided into what? Into 3 components. So we have current 1, current 2, and then current 3. So current 1 has a value of 0.61, current 2 has a value of 0.4, current 3 has a value of 0.24. When we add all that, we have 1.25, and that is the current that is passing through the circuit. Okay, so this is how we go about that. Now when it comes to other three resistors, that is resistor 4, resistor 5, and then resistor 6, they are going to have their own potential differences. Now resistor 4 and resistor 6 have the same value, so at the end of the day we expect them to have the same potential difference. Resistor 5 has a different potential, has a different resistance from the other two, so it is going to have a different potential difference. Okay, so in our next lesson what we'll try to do is that we'll try to calculate the potential difference V2, the potential difference V3, and then the potential difference V4. And then we expect that if we do that right, then this potential difference 1.213 volts that we've already determined added to V2, V3, and V4 should be equal to what? Should be equal to this 10. I hope you get that. Should be equal to the 10. Yes, so that is the situation that we have now. I think that it is clear enough. Okay, it's clear enough. And one thing you must bear in mind is that if we have a circuit diagram like this, we start by attacking the parallel connection, we deal with it, we get the overall effective resistance for the parallel connection, and then we add it to all the others that are in series, and then we get the effective resistance in the circuit. When we finish with that, we come to the batteries or the cells, and then we find the effective EMF in the circuit. And then we can go and calculate the overall current in the circuit, and then we can then go on to find the current through each of the resistors that are connected in parallel. But to do that, first you must find the potential difference across that connection, and this comes into play. The effective resistance for the parallel connection comes into play, multiplied by the current that will give you V1, or the potential difference across that connection, and then you can go on and calculate I1, I2, and then I3 like that. Okay, so I think that it has been fruitful. It has been wow. So this brings us to the end of this particular lesson. We'll solve more questions. We'll solve more questions in order to make things clear. Thank you for making time to be here. If you have some questions or comments, as usual, you can go to the comment section and then you put them there. All right. I'm always there to respond to your comments. Okay. So until I see you in my next video, remember, as always, take care of yourselves and each other. All right. Remember, let's keep learning, because learning is fun. Bye-bye.